For letter A, you guys should have already figured out the intersection points between this dude and that dude. The function and the horizontal line is negative 1 and 1 just by setting them equal to each other. B says, and actually, does anybody have a question on C? I've had quite a few people asking me about C. Okay, let's talk about B and C real quick. Both of them use the same function f of x with the same region R in some way, shape, or form. I'm going to go ahead and put the graph right here for us to reference. It's something like this. We have this right here, y equals 3. We have our f of x right here. We have our region R. That's all nice and shaded, and this is negative 1, and that's positive 1. Okay. B says, write but do not evaluate, so we don't have to actually solve an integral expression. They're giving us a hint. It's an integral for the volume of the solid generated when R is rotated about y equals 7. 7? Isn't 7 up, guys? Right? 7 is up, so this thing has to rotate up. And not even up. There's 6. 7 is 1 above. So I was trying to get a nice picture of it. So therefore, if I need to rotate around this guy, whoa, isn't that going to be a washer? But what was my hint? Always, always, always go from the axis to the outermost. True? From the axis to the outermost, and that's going to be my big R. And then from the axis to the hollow. True? So if the axis is 7, V equals, it's spinning, so it's high. And who squared? Big R squared minus little r squared. Now careful, big R already has a meaning. So I'm going to go straight into actually plugging in instead of making big R something else from the problem. So I'm going to use the top, which is 7, minus, well, the outermost of the shading is 3 squared. And that's big R squared minus little r squared is 7 minus my function 6 over 1 plus x squared. And everybody says, praise the Lord, we're not solving. Wait, it abounds. Negative 1 to 1. Ha! And I'm done. Simplify. No, heck no. I'm leaving them. All the numbers are plugged in. Nothing for me to solve. It says write but do not evaluate. Check. Done. Okay, number C. Letter C. It says let h of x be the distance, the vertical distance, less u, the up-down distance, the top minus bottom distance, between the point x, f of x, and the horizontal line y equals 3. Now, just to give you an honest peek into my life, this morning I was like, oh, it's x, look, and I just naturally put x in between negative 1 to 1. I was like, okay, vertical distance, go up and hit this, and then go, oh, there we go, f minus 3. And I was like, yay, let's go, and we solved it. The problem is, what did they say a little bit later about who x actually is? X does not belong on this side of 1. Where does x belong? This side. So wait a minute, if that's the case, where's my f? Way down here. And where's my distance between the x, f of x, and the horizontal line? I have to go up. So here's my question. Who's higher? Who should be first in the subtraction? 3. So therefore, h of x is the vertical distance. 3 is higher. F of x is second. I'm supposed to find h prime of x based on find the rate of change of h with respect to x. So not a dh dt, but guys, rate of change. Do you notice this was up for the entire forever course? Fine? Anyway, rate of change of box. There wasn't much. Integration is net change, or maybe FTC, but anyway, rate of change. Average rate, maybe. Anyway, rate of change is a derivative. That's not a dh dt, it's just a good old-fashioned dh dx. So I would go ahead and take the derivative of 1. I would rewrite it. Double check. Is it 1 plus x squared to the negative 1? Is that right? So I would bring down, well, derivative of 3 is 0. Bring down the negative, and negative is a positive. I would have 6 over 1 plus x squared to the second power times u. And all I have to do to finish is just say, oh, let's plug in 2. It's like, fine, but don't take away my points. Not today, not today, not today. Okay, what else do we have? Kevin, you had some.
Number 6, C for Saturday.
Saturday, 6, C. Number 6, if I was to give a title to this guy, I would call him, I don't know, the implicit guy? The implicit guy, the differential equation guy, something like that. So I have this beginning situation up here. I'm going to steal just really quickly that equation because I think we might need to use it. I'm going to C, right? Okay, I have this guy if I need it. So going to C, determine the concavity of the curve at points for which y is in between negative pi over 2 to pi over 2. Give a reason for your answer. Well, it says determine the concavity. Well, guys, concavity, don't I have to look at the second derivative? Now here's the question. Have you had to find the second derivative yet up to this point? No, no points of inflection that I had to worry about. I mean, tangent, that's first derivative. Oh, they told me what the first derivative was. So if you guys don't mind, you were supposed to do that in letter A. I'm going to steal the first derivative and not find him again. So dy dx, uh-oh, help me, it was 2 minus, is it 2 over?
Yeah.
Okay. If that's my first derivative, second derivative, I don't know about you guys, but once again, I do not like quotient rule. So I'm going to make this to the negative 1 power. So I'm going to take the second derivative, deriving this side, would be bring down the negative. This is now to the second power, or I should say the negative second power, times u prime, and the derivative of 2 is 0, derivative of negative sign is negative cosine of y, but don't forget your v prime. I still have dy dx. Oh, that's okay. Don't I know who he is? Yes, I do. So technically, I have negative times a negative is a positive, 2 cosine of y, all over 2 minus sine of y squared times 2 over 2 minus sine of y for my second derivative. Sorry, I'm looking at this instead of the question I'm supposed to be looking at. Letter C. Determine the concavity of the points. They tell me y is only allowed to be between negative pi over 2 and pi over 2. So technically, according to this, that means I'm only looking at angles going up 90 and down 90. So in the first quadrant and the fourth quadrant. The concavity, I need some sort of sign. And according to them, man, it sure sounds like it should be just one type of concavity, just one sign. So if I go ahead and think about y is in between negative 90 and 90. And if I look at my trig functions, because remember, in this one, everybody is positive, and this one, well, cosine's positive, but sine's negative. I'm going to come down here and be like, well, cosine's a positive. Okay, positive, positive, positive. Sine's a negative. Oh, wait, but minus a negative is a wait, it's squared. It's positive anyway. Oh, sine's a negative. Oh, minus a negative is a positive. Guys, if I have all positives, what's my concavity? Because second derivative. Just using my trig knowledge is always positive, therefore y is always concave up for y within. Doesn't mean always, always, and forever, but for these angles, only up. Is that okay? I'm ready. Anything. Saturday, Wednesday, FRQs 3 through 6. Multiple choice, someone have something? I'm ready. Dean, you're ready.
Saturday.
Saturday 90. Saturday 90. That's calculated section, so maybe we get to use it or should use it. Maybe we shouldn't. Oh, I don't think we need our calculator. 90. Do you guys see some calculus in there? They give me a table, but then they say select values of the increasing function h. I think they're giving me a clue. Oh, my smartboard sucks. Selected values of the increasing function h, and its derivative h prime are shown in the table above. If g is a differentiable function such that h of g equals x, for all x, what is the value of g prime? Well, I see h prime there, and I see g prime over here. Now, here's something interesting. How can I get g alone? Just using like pre-calc. How do you undo a function to get g alone? What does g equal? How do I undo h? They're hiding the fact that g is really h inverse of x. The composition of a function with its inverse is x, so g is h inverse. Wait a minute, do we have a card for how to take the derivative of an inverse? F inverse prime of x is equal to 1 over f prime of, well, if that's an A, that's a B. Well, if I'm trying to find the inverses prime, which I am, that'd be h inverse prime of 7. That's another way of writing that. That would equal 1 over h prime of 7. No. Remember, f of, oh, is this B and not A? No, that's B and not A. There we go. So I have to go ahead and match and say the 7 belongs here. So the 7 belongs here. So I would do a 3, and 1 over h prime of 3 is a hidden derivative of an inverse. Cool kids. You might not be totally done, but at this point you should be mostly done, and that's all I'm looking for. I'll have it by the end of school if you want it back to study. Mock APs, the ones with the Scantrons, in my hands. See you guys later.